So we are talking about data type modifiers in this lecture. So there are basically four types of data modifiers. One is called long, one is called short, one is called signed, one is called unsigned. So you can use these data type modifiers along with the data types to increase or decrease the size of the box that is allocated in the memory, right? So we have seen that when you're allocating an integer, it by default the compiler allocates a 4-byte box, right? So if you say okay, int x equals to 5 or int x equals to 15, so you will get 4 bytes in the memory to store the value of the variable x. So this whole box is x. But somehow suppose you want to store a very large number, you want to say okay, this number is 1.5 into 10 raised to the power 12, then int is not sufficient to store this number, right? So what you need in that case is you need a long int. Long int will expand the storage, and instead of saying 32 bits, now your x will have 64 bits, right? And generally we write long int, right? So long int does not work, so you have to write long int. So you will say okay, so long is a data type modifier, right? So it allows your box to get a larger memory than 32 bits, and you will get 64 bits, right? So if you check the size of long int, you will get 8 bytes. So let us try to use this, right? So similarly, short will reduce the size, long will increase the size, and signed int will give you 1 bit less, and unsigned int will give you 1 bit extra, but it will work only for the positive integers, right? So if you want to work with long positive integers, you will select unsigned long int, right? So let us see what is the range of this, right? So let me say you have unsigned also, right? So let's say int x equals to 10, and if I do okay, let's say int x, and let's to see out size of x, and let us also see what is the maximum number that we can store in x, right? For that we can have this header file called climits, and it contains two special constants. One is called int max, another is called int min, right? So if I do cout int max, this denotes the maximum integer value that can be stored inside an integer. So if I do cout int min, and this denotes the maximum value I can store inside an integer. So let us store int max in x. Okay, so let's run this code now. Data type modifiers. Okay, so it's not data types. Okay. So /data type modifiers. So you can see this is the number, right? So you can count the number of digits: 1 2 3 4 5 6 7 8 9, right? The largest number that you can store in this is of the order 2 raised to the power 9, and the similar number in the negative range, except with the difference of 1. You have a 7 here, you have a 8 here, that we have seen, right? So this number is nothing but 2 raised to the power minus 2 raised to the power 31 to 2 raised to the power 31 minus 1. So this is the int max, and this is the int min, right? And now I have a very interesting question for you. What will happen, right? What will happen if you add 1 to x, right? So let us do cout x. So will it be able to store the value of x, or will it not be able to store the value of x? And cout, and let me do x equal to x plus 1, and let me do cout x now. So let me just remove this, right? So let's see what is going to happen, right? So maybe let me say cout x, and let me say cout updated x. So make your guesses, and let's see what is going to happen now, right? Now you can see, so x is going to store the value of int max, but the updated x is storing the value of int min. So how it is going to happen, right? So this happens due to a special uh, due to the way the bit system works, right? So this phenomenon is called wraparound. So whenever you will try to exceed the maximum range of int, you will end up on the opposite side. So if this is 0, this is int max, and this is int min, right? So if you try to jump beyond this point, you will end up here, right? And if you add 2 here, you will end up here. If you add a larger number here, you will end up here. If you add a very large number here, you might end in the positive side as well, right? So this can lead to wrong answer many times. When you're doing online problems, you have to analyze the constraints very carefully, right? So analyze the constraints. Suppose the problem says you will be getting n numbers and range of each number a will be less than equal to 10 raised to the power 12, then definitely it's a big hint that you must not use the int data type, must not use int data type. Instead you should use the long int data type, right? Because this is greater than 10 raised to the power 9, and if a number is greater than 10 raised to the power 9, it will lead to wraparound, and that will, it's also called overflow, right? Integer overflow. So it will overflow this limit of int max, and you will get a wrong answer, right? Because of the overflow. So you have to be very careful with the constraints that are given in online problem statements, and those constraints are basically given so that you decide the correct data type and the correct data modifier for the given problem, right? And those data modifiers can be different for different kind of variables. For example, you're given n and it is given n is less than equal to 1000, then you can take int for it, but it is given followed by n numbers, so you're inputting a number. For that you might require to have a long int, and it is given number is less than equal to 10 raised to the power 15, right? So your long int can store up to 10 raised to the power 18, right? And if your number by chance is greater than 10 raised to the power 18, then you have to work with big integers, and I will prefer those problems should be solved in Python, right? Okay. Or in Java, right? With C++ you have to again make arrays and do some complex computations, but that can be solved very easily in Python, right? But it would be a very rare case, right? So you will get a big integer problem, that would be a rare case, right? But if you get big integer problem in which you have to work with numbers which are greater than 10 raised to the power 18, I will suggest you work with Python in that case, right? That's all for this video, guys. Hope you enjoyed this and learned the concept of wraparound and data type modifiers. Thanks a lot. See you guys.